but you won't have time for this coding session. If you want to join along, click on register here. You'll be able to register with Google. You'll hopefully be able to get to a demo cluster. It's like a playground cluster where you can play around. You'll get 14 days free access. You'll be able to follow what I'm doing. Okay, so you go ahead and do that if you haven't done it before. If you haven't done it before, let's jump straight in. I'll just show you what happens in Hopsworks.ai before we sort of do any more. I have a cluster already running. I'm not using the demo cluster. I've actually connected my cloud account, and you can connect your cloud account, so AWS or Azure, to this Hopsworks.ai platform. So what that means is you create something called a cross-account role in AWS, or a subscription and tenant ID in Azure, and then we're able to launch a cluster in your account. And that's what I've done here. So I'm going to work from this cluster here. Just one thing to note, I'm going to actually, yeah, you can see I've opened up the ports. We're going to do a Python example from a Colab notebook later on. So I'll need to click on these open ports, because otherwise the cluster won't be accessible from outside of this. In this case, it's Azure. It's not actually, when I say open, there's still, of course, access control, and there's two-way TLS certificates used to encrypt the connection and links. But it just means that the ports on the VPC are actually, traffic is allowed to go in on them, but they're reaching endpoints that are, of course, secured and authenticated and access controlled. All right, so let's jump in. If you click on the cluster link, you'll open your cluster. It is actually a cluster running inside your account, so it's going to do, it's going to sign me on again. I was already signed on, and I'm going to go with the new UI. So I'm going to click on this try new Hopsworks UI. To speed this up a little bit, I ran the demo project. So when the first time you log in, there is a demo project that you can run for the feature store, and that's the one I've done here. And when you run it, you'll get a job that completes. I ran a couple other jobs here, but it's this one here at the bottom, the feature store tour job. And you can see here that it generates a bunch of these feature groups in here. And we can see there's a bunch of them in here. So what I'm going to do straight away is I'm going to run a Jupyter notebook, because I'm going to start out with the first kind of exercise. We're going to create some features. We're going to do it in PySpark. Later on, we'll do the same thing in Python. So we're going to create features in Python. We're going to create them in PySpark, and we're going to write them to the feature store. And they're going to end up in these feature group area here. So you can see I actually just started a notebook earlier. And when the first time you start it, it'll actually ask you if it's going to open. It runs in the background asynchronously. So it'll ask you, do you want to allow this to open a new tab for you? And you just say yes, allow it. This is the notebook here. So I'm not picking a random notebook here. I picked the notebook called HSFS Basics. You can see it's in the HSF folder. And then inside that, we have a bunch of notebooks. This one is called Basics, not the Snowflake one. And the reason why I picked this one is because if you go to this really great resource here called examples.hopsworks.ai, you'll see there's a bunch of notebooks here, and there's a lot of notebooks covering lots of different territory. Now, if you go to the very beginning, it says try now on Colab, and we'll do that in a minute. And then after it says create your first features. So I'm going to run this first notebook, the feature engineering and ingestion notebook. And if we go back to our notebook, that's this one here. It's in the HSFS Basics directory. And you can see it's a Spark application I just connected already. So that connection exists. And now we're going to run through it. So I'm just going to run a couple of tabs and talk about them as they're running. So what I'm doing in this case is I'm going to read up some data. In this case, we have some information about stores. So they're selling goods, and it's a CSV file. And we also have sales in those stores. It's another CSV file. And this comes with the platform. It comes when you create the demo project, these data sets are there. And another one called exogenous CSV. Now, we could in the notebook, we could do some exploratory data analysis of them to see what they look like, their schema, and so on. There is a slightly quicker way in the platform to do that. And I'm going to just go to it with the old UI. We have dataset browsers. You can actually, file set browsers, you can actually look at those files. So those files are in here in the Jupyter folder. So I'm in datasets here in the project in Jupyter folder. And in here we have the HSFS directory. And in archive, we have these files. So you can get a quick look at them by saying, okay, what's the store data look like? Preview it. Well, we can see there's a store, a type, and a size. We have some sales CSV file, and we can see in there we have store, department, date, weekly sales is holiday. And then in this feature set, which is the exogenous features, we call them, it's basically what's the temperature like outside, what's the current date, what's the fuel price. These are features that are external to the store and the sales, or what we call exogenous, but maybe they influence sales at the store. Okay, let's go back then and look at our notebook. What we've done is we've read up these three CSV files as data frames. So they're Spark data frames. This is a Spark program. And we're going to do some simple feature engineering to get started with. We're going to take the data frame stores CSV, and we're going to join with it some sales from the sales CSV data frame. And we're going to group by store, and we're going to count the number of sales by department. And we're going to rename the column that we're creating here called count department to just calling it number of departments. So it's going to count the number of departments actually in that given store, and that extra column here, we're going to add it to the store CSV. So we're going to just count the number of departments in a given store and add it to our stores data frame. It's now called stores FG. So what we do is basically we're going to write those features now about the stores, and we've added this new column which is telling us the number of departments in a given store to it. We're going to write those to the feature store. So to do that, you can see here that we have some code. We have creating a feature group here. We have the name of the feature group. We have the primary key for it. So store was the primary key decided, and then we're computing some statistics over it. Now at this point, I'm running along here quite quickly, but you can ask questions in the chat or Q&A up here. So feel free to do so at any time. And that button should disappear, but it didn't. Okay. All right. So I ran this one, and it should have written the store feature group. So we can go back and have a quick look in here. We're going to go back to the feature groups. I'm just going to have to refresh here. Let me remove myself from this. Okay, so we should have a store feature group that got written out here. And we can see there is one here. And in fact, the sales feature group is here already because I ran this earlier. So maybe I'll delete this one before I go any further. Let's go in and delete this one because it's going to create it in a minute. Okay, let's try and delete. Okay, delete that feature group. Okay, so created the stores feature group and it wrote it to the feature store. If we go back and look at the code just for 1 second, we can see that there is a flag here called online equals true or false, and by default it's false. So it only wrote it to the offline feature store. And if you're curious about the APIs, you can go to docs.hopsworks.ai. And there's a bunch of links here. We'll go to the feature store link, and the APIs are in here. So we can see we're using the feature group class here, and these are all the options. A couple of them that are relevant and useful. I mentioned online enabled as false, but if you want to write to the online feature store, you set that to true. If you're running on the open source version, you will need to set in the connection object here, you're going to have to set the hostname verification to false, because when you install the open source version, you get a self-signed certificate by default. And we'll see later on that we use an API key value when we're connecting in Python, but it's safer to use an API key file or a secret store. So we're using the feature group API here. There's a bunch of other ones like specifying partition key and expectations on feature groups so that the values fall within particular ranges and so on. But we're going to skip over those for the moment. Okay, so we're back here, and I just refresh this here. So we're going to look at the store feature group here. And this is the one that we just wrote. You can see there's 4 features in here: store, size, type, and number of departments. We can see there's no information about provenance. We're not using it in any training data sets yet. We haven't created tags. There's no alerts for it. And we can get alerts that every time, for example, we successfully write or fail to write to this feature group, we can get an alert on Slack or PagerDuty. And we can look at the statistics of some of the features that were written. Okay, oops, we go back. I click back button very quickly. Phone in case anyone's curious. Okay, so you can see here these statistics of the features that were written. We wrote, I'm not sure how many rows we wrote total, but we can see that there were 12 distinct departments, number of departments. You can see a bunch of different, and the number of stores that had this many departments follows this distribution, and the mean was 79. And then we can see the size of this stores and the distribution of the values and the store ID. This is not a very useful feature. When you're working with feature stores, the IDs of these feature groups, the primary keys of them, you'll need them when you want to retrieve the features in the online feature store. But when you're training, you typically don't use these primary keys. They don't have any information carrying value or predictive qualities. And then finally, we have the type of store here that we have down here. Okay, so there's a bunch of other things like feature correlations can be computed here as well. I didn't compute those, and you can get a preview of the data. And if we click on the preview of the data, in this case, the data is in the online feature store, sorry, the offline feature store, not the online feature store. So that's Parquet files, and we wrote them with Hoodie. So it's going to start up a Hive query to look at that data. It takes about 20 seconds to do it. It's not super fast. If it's in the online feature store, it's much faster to preview your data. It's just something to be aware of. So let's jump around. No, let's just check if there's any questions coming in here. None for the moment. Okay, we can see some of the data. So this is a preview of the data. We can see the number of departments. There's quite a spread around the 60s and 70s, the size of the stores, the store IDs, and then the types of the stores. You can see it's a categorical variable there. All right. Let's keep going through the notebook. Actually, we jump back to our notebook here. And what we're going to do is a bit more feature engineering. This time, we're going to compute sales. So if we, and Spark, as you know, this went very fast because Spark is lazy, as you know, so it's not actually done anything yet. This feature group exists, the sales feature group. So I'm going to write a new version just to show you that we can write a new version of a feature group. And what I'm going to do is I'm going to write this particular data frame, sales_FG. So this data frame sales_FG contains aggregated feature engineered counts of sales over given periods of time. So sales in the last month in a given department in a given store, sales in the last quarter in a department in a store, in the last 6 months, last year, sales in the last month in a store as a whole, in the last quarter in the store, in the last 6 months, and last year in a store. And what we can see here is that, well, how it's computing them, what it's doing is we take, if we go back and we look at the original CSV file sales, it tells us the number of sales in a given time period in a given store. What we can do is we can partition by the store and department, and then order by timestamp, and then we can get a range of 30 days. So, and then we're basically partitioning it up by 30-day amounts, and by quarters we're partitioning it up by 90 days, and half year 180, and 365 days per year. And then what we're doing is we're using, if we look in here, we're using this f.sum, which is part of PySpark. It's a function that we're importing to compute all of the weekly sales over that given window. So this is very simple feature engineering in PySpark. What we can see here is that we created the feature group, and we didn't compute statistics. So it goes faster if you don't compute statistics. We can now, this is creating version 2. Version 2 may exist, so we'll see if there's an error in a second. We can go back and look and see what versions are there. And we've got another version 3 here as well. So let's go back and look and see. We created version 5 there. And I'm going to just go back to the notebook here. We can close that window. Here we go. So let's go back to here, and we've got this sales feature group here. So we'll just refresh just to say we have sales FG here. Now, if we look at the sales feature group here, we can see there's 13 features. These are all of the different sales by department and store. We can see it says version 5 is the latest. That's the one I just wrote, but there are actually a couple of older versions. So when I deleted it earlier on, I actually only deleted one version of the feature group. I should have deleted all of them. So we'll look at version 5 because that's one we just wrote. And we can see we can get a preview of the data again. We can look at activity. We didn't look at that already. This feature group was created and we wrote some data to it. And you know, the kind of cool things you can do as well is you can, you know, I can say, well, this sales data maybe has personally identifiable information. So I'm going to just label it quickly so that we can see. And we're going to label it with a keyword so that you can create both tags, schematized tags, and these keywords. So in this case, I'm going to create a keyword and then save it. So I call it PII. So then if we go back into our list of feature groups here, we can see that if we just need to refresh this, that if we look at the sales feature group, and I'll need to actually, you can see it here, it's version 5, it has this PII label. And then if we go and search for it up here, I can search for PI, not just PII. You can see it'll find it, it'll match in the tag. So if I search PII, that's great, it'll find it. Spell it a bit too wrong, PII, and it won't match. Okay. Right, let's move on in the notebook, and we're going to create a couple more feature groups here. We're going to create the exogenous one. And this exogenous one is going to have these external features that influence sales. And then you have a bunch more feature groups here. So let's keep going. And we can see that these feature groups that we create, the exogenous one, we're going to create it here. And we're just adding a column called date to the CSV file that we read in as a data frame. And we can see that there's two-part primary keys. So primary keys don't have to be a single column in your data frame. They can be multi-part. And in this case, we're actually computing statistics on this particular feature group. So what you can do as well is that you can append additional data to the feature group just by calling insert. And in our case, when we save this data frame, this is a data frame exogenous FG to the feature group, it's going to create the feature group, in this case version 1, and it's going to insert that data. But typically in a pipeline, you won't have to create the feature group, it will already exist. You'll get a reference to it. So you can see we have this line here, exogenous underscore FG underscore meta equals FS FeatureStore.get feature group, and then we give the name of the feature group and the version. And the version is important to provide it because if you want to write pipelines, and if you want to write, do ML ops, you need to have version feature groups. So you can keep writing the data every day or every hour that the features get updated to that particular version of the feature group. And if somebody wants to create new versions, they can do it on version 2 or version 3 or version 4. And only when you need to then, you're happy that all of the pipelines, including the training pipelines, not just the feature pipelines, are correct, you can then move to the latest version. So what we can see here is also that the typical use in a pipeline will be get a reference to it and insert the data. And what this will do in the offline feature store is it will write it using Hoodie to Parquet files in our platform, and it'll write to the online feature store, which is RonDB in our case. And what we can also do is we can append a feature to a feature group. We can that will alter the schema, and it'll give us a new version of the feature group, and we can delete them, of course, as well. Okay, so if we go back, then I guess at this point there should be maybe some other feature group in here. Did exogenous? I don't remember. Yeah, exogenous came in here, and that particular feature group had statistics computed. So we can see, and maybe there were correlations computed as well. We can have a look at them in a second. So we can see we have the fuel price is this variance, and there's a bunch of them here. These are temperatures. You can see it's kind of a normal style distribution. So if we look at, and maybe the correlation matrix was computed, I don't remember. No, I turned that off. Now, that's pretty much writing features into the feature store. These features are reusable. You can reuse them to create what we call training data sets. And a training data set it's files in TF record or CSV, and the file format that you would expect to use to train a machine learning model with in scikit-learn or PyTorch or TensorFlow. And you're basically selecting these reusable features. The features in the feature groups, they're mutable. They keep getting updated, refreshed, kept fresh, latest, freshest values. But our, excuse me, our training data sets, they're immutable. They're just a one-off snapshot. And we know the range of time that they're created over, and we know the set of features they include. So I'm just going to show you briefly how you would create one from the UI, but you typically would do it from a program. Let's say I want to do like store sales prediction or something like that. I can basically pick out where I'm going to store this training data set. Now, if you're working on SageMaker or some Azure Machine Learning Studio, you might say, well, I'll store it to S3, a bucket in S3, or I might store it to ADLS. So you need to create something called a connector to do that. And you can go in storage connectors to define them there. I haven't done it, so I don't have one of those available. But I can create one with, and the file format you can pick, TF record, CSV, whatever. I'll just leave it at CSV. and then you can compute statistics over these training data sets. So I'll just show you what I mean by saying you can reuse features. What you're doing is you're selecting features. So I can say, well, I'm going to pick features from the feature groups, and maybe I'll go from the sales one, and I'll say, yeah, I'd like to have the store ID because I need to know the store ID and the department ID. And I'm interested in weekly sales, and whether it's a holiday or not, and maybe just sales in the last month. I'm not interested in too much more. And then I can go back and say, well, are there any other features that I'm interested in? Yeah, I'm interested in the temperature, let's say. So for a given store at a given temperature, a given date, I'd like to know the temperature. Did I add that? Yeah, we have it in there. Okay, so then I can basically say, okay, these are the features I have. Sales weekly, if it's a holiday, and then the temperature at a given store. And I'm going to pick the store ID, how I join them together in this case. So we have this store here, and then we have the sales one here, which has store. And then I can go ahead and create a train data set with this. And I might decide, well, I'm going to have 20% training and 80% test, or 20% test and 80% training data, and it can create a random split of the data for me here. And I can go ahead and do that. What it's going to do is it's going to launch a Spark job in our platform that will actually now create that training data for me. So it's just written the metadata in here, but the training data we'll get, and we can have a look at the jobs here to see that this is the job that's just been launched. And you can see it's just started. We have a look at the execution. Jobs are quite similar to notebooks. We have Spark UI, we can monitor them, and so on. So when that job kicks off, it hasn't quite kicked off yet, it will have a Spark UI available. So we can kind of jump in there, and it'll take a couple more seconds, I guess. I hope I didn't use up all the resources on the notebook. But if we look at our notebook, we can see the Spark UI because this one is still running here. This Spark job that I have running here, you can see there's quite a lot of stuff going on it. Okay, let's not spend too much time on Spark. I'm going to go to the Python client now. Again, if you have questions, you shout them out. We have one here. So Sridhar asks, could you explain about connection with Oracle JDBC and write features in the Oracle database? I tried, but I'm not able to. Okay, I mean, I won't be able to debug your problem, Sridhar, right here, but so you want to read, I assume in this case, you want to read from an Oracle database. So Oracle JDBC database, and you want to write features from the Oracle database. So let's have a look at how it should work. So you should be able to go in to set up a storage connector. And in Oracle's case, we'll choose a JDBC storage connector. You put the JDBC URL to your Oracle database. You'll need a username and password. You can encode it in the URL or as key value pairs here. And once you've created that storage connector here, it'll appear in here as a name. Then you can go and create what's called an external feature group. So this is, an on-demand feature group. They're external tables. The external feature groups are on-demand feature groups. Let's go back here. They look like this. You can create it in code, or you can create it in the UI. But they look like this. You can see it has a storage connector. You have the SQL statement that you want to call in your Oracle data tables, or in this case, it'll connect to your database, and you'll say, select these features or these columns from this table, and you may have a where clause, and you can do aggregations and all sorts of good stuff here. And basically what you get out, and whatever you've selected, are these features that came from this table, season score features 1. So they should appear in here, and these features in this table are usable like any other features that are written to the platform or coming from any other platform. So we actually did a blog post this week about Snowflake. So there's a little bit more detail. You can see if you look at the Snowflake example here, if you just Google Snowflake Hopsworks, I think you'll find it. This is showing how to set up the Snowflake storage connector and a more complicated query. You can see it's computing some features, so average of the profit sum and so on. And then you're basically, this is showing you how to do it in code. You call create on-demand feature group with the SQL query and then storage connector. And you can also compute statistics for it. So the question is, why doesn't it work for you? Often the problems are network connectivity. Can you connect from our platform to your Oracle database? Are your credentials correct? Are you running open source, or are you on the enterprise version? I'll be honest, I'm not 100% sure if it's available in the open source, the connects. I think they are. And if you're on the cloud platform, yeah. Okay, so let's move on, and hopefully that kind of answers your question. All right, okay. This is not appearing. All right, no more questions at the moment, but please shout away if you have more questions. So I'm going to run the Colab example. I won't have a huge amount of time to do anything else in this in the last few minutes remaining. I'm going to run a Python notebook, and if you click on the examples Hopsworks.ai, you get this notebook. You should always make a copy of it just in your drive to get started. So I just create a copy of it in my drive in Colab. And if I just run through the cells here, just get started, the first one here, you can see the first thing it does is it tries to install our library called HSFS. And you should install it with the Hive option, or we're going to change that to Python to make it clearer. But this is the Python client, right? So it's going to install the library. And then we need to connect to the feature store. So you can see here, it tells me there's a bunch of options, and I haven't filled any of them in. So I need to fill them in to connect. So let's do that. So firstly, oops, okay, we can remove that comment here just for, we leave the comment there. Firstly, we need to connect to the UI of our, or sorry, the domain endpoint or host name of our feature store. So I'm just going to copy it from the URL bar here. Let's put that in here in the connection host. You can put in an IP address here as well. In this case, I'm putting in the host name or domain name. What I need to do as well is I need to create an API key. So I'm going to go ahead and do that. So I clicked on account settings there, and then I go to API keys, and let's call this US East 1. Let's just call it US East, and in acknowledgement of US East being down today on AWS. Okay, so I save that key. And then, you should save it in a file. Don't do what I'm doing here. Don't do this at home, folks. Don't paste your API keys into your notebooks. Bad things will happen. And then the last piece of information I need to fill in is a project, because you can actually have many projects in the platform. And if I go back here, you can see I only have one project. This one here is the one I was inside, but you could potentially be connecting to different projects, and each project can have its own feature store. So I'm going to paste in that project name in here. And I already opened the ports on Hopsworks.ai. I think the ports are, if you're curious about what the ports are, I wrote them out here. In the installer script, if you're working with open source, you'll need to open up 443, 8020, 9083, 9085, and 5000 or 50,010. So, okay, that went okay, went pretty quick. And then it connected, no complaints. If you have, connectivity issues, if you're not able to, like if you're running, for example, the cloud from Databricks or from SageMaker, you might have to set up VPC peering between the networks and get that working. So you can see here, then we're able to read from the feature store, and it was pretty quick. And we can also write and create features. And in this case, I'm creating features in the pandas data frame, and I'm going to write them to the feature store. So I just downloaded a CSV file here, and I created a feature group, and I'm saving the contents of that. What's actually happening in this case is the Python program here is writing the pandas data frame to the feature store, and it's going to start a job to do the ingestion. So in the case of, and you can see it's running here. This is the job oh no, sorry, it's this job here, the one. And we can see it's running, and I can have a quick look at the Spark UI for that. So that's ingesting the data. So that's the way it works for the Python client in terms of writing. It's slightly different. Okay, that's the pretty quick intro. Thanks for listening and paying attention. You can get more help here on Hopsworks community.hopsworks.ai, and you can ask questions, and we'll try and be as quick as we can. Sorry, I can just see from Pratusha has an Oracle JDBC question which just came up there. So somebody should have answered this already, but they obviously haven't. But I'll have a look at it and try and answer it after this. Thanks everyone for listening, and please reach out and get trying and doing your own